Hello guys, welcome to Backbencher Studies channel. In the last video, we have discussed about the first order system and how we can solve the transfer function of this first order system. We also analyzed this first order system based on a given input, that is a impulse input. So this test signal which is being fed into this first order system gave us some response of this system which is kind of similar to this impulse response with a lack of ideality in the system. So let us give the one other step input, a test input, which is the unit step input. So if we analyze based on giving this unit step input to this first order system, what we can get, let us see in this tutorial. So response of the first order system, if this test signal is unit step. So remember, this unit step signal is containing only DC component, that is for t greater than or equal to 0, then we can have a constant value of the signal which is 1 if it is unit step signal. So if we apply Laplace transform to this signal, then what we can have is a 1 by s in the frequency domain, which is the Laplace domain. So we can substitute this R of S in the output equation of the first order system, which we have derived in the previous slides. So let us start our session. So we have, when this input signal, when it is the unit step signal, we can have the Laplace transform as 1 by S. So if the output equation is considered, and if we substitute R of S equal to 1 by S over here in this output equation, we have what is called this equation 1 by S into S tau plus 1. So we need to kind of apply, we need to transform this into time domain. So we need to apply inverse Laplace transform on both sides in order to find out the time domain equation of this output signal. So but we cannot apply this. There is no direct formula for a system of equations, or for a S domain equations of this form. We have the Laplace inverse transform for 1 by S, that is the unit step signal u of t. And if we have 1 by S plus a in the Laplace domain, we have the inverse Laplace as e power minus at. Remember the time shifting property. If you have not watched that inverse Laplace transform, please do watch that. It is being uploaded in the signal and system course. So if you are thorough with this inverse Laplace transform, we can easily solve and we can easily analyze this first order system or second order system. And time domain analysis is kind of easy thing if we have the Laplace transform in our hands. So to solve this, we need to apply the partial fractions. So if we kind of write this in terms of partial fractions, we can write this as a by s plus b by s tau plus 1. So if we kind of do this LCM and equate this to 1 based on different values of s, if we can find out this values of this a and b constants. So if we do that, so if we so we have done this, and if we do that, if we substitute s equal to 0 in this equation, we can have the b eliminated over here. And if we substitute s here, s equal to 0 over here, then this one will become a, which is equal to 1 over here in the right hand side. So if we substitute this s equal to minus tau, minus 1 by tau over here. So if we substitute s equal to minus 1 by tau over here, then this one will get cancelled with this plus 1, thereby eliminating the effect of capital A in this equation. And if we substitute s equal to minus 1 by tau here, then what we have is b equal to minus tau over here. So if we substitute this a value and b value in the previous expression, what we have, so if we substitute a equal to 1 over here, then the corresponding output equation in Laplace domain will become 1 over s plus minus tau by s tau plus 1, just like that. Here we have this equation, output equation in Laplace domain. So if we take this tau constant, which is common from this, then we can have 1 by s plus a kind of thing. So if we apply inverse Laplace transform to this, so we have already seen that this is the inverse Laplace transform of unit step signal, which is the input. So if we kind of apply inverse Laplace transform to this one will become 1 into u of t. And if we observe this, and this is kind of 1 by s plus a in the Laplace domain, if we apply inverse Laplace transform to 1 by s plus a, then we can have e power minus a into t. So similar kind of thing that is being written over here. This is the output of the first order system when we apply this unit step signal to this system. So if we plot this output in the graph, then what we can have is this kind of graph which is being shown over here. So this dotted segment shows the input to this first order system. So if we give this unit step input to this first order system, then we can have a constantly reaching to its steady state, the exponential signal which we got in this previous slide. So this is how we can analyze the first order system using unit step input. So if we gave another input, which is the ramp input, we already saw that ramp input is nothing but r of t equal to t in the time domain. Then if we apply frequency domain, Laplace domain transformation, then we can have r of s, which is the input Laplace domain, is equal to 1 by s square over here. So if we substitute 1 by s square, and if we kind of apply partial fractions in this, so similar thing which are we doing in this analysis. So what we are doing is nothing but the we are substituting the r of s based on our input, and we are finding out the inverse Laplace transform of this equation, which is the output equation. So we have 1 by s square into s tau plus 1. If we kind of write this in partial fractions and solve the values of a, b, and c, and if we apply inverse Laplace transform, so this is the value of the output signal in the s domain. So if we apply the inverse Laplace transform of 1 by s square, what we have is the input signal, which is the r of t, which is nothing but t into u of t. If we apply inverse Laplace transform to this signal, what we have is the unit step signal, which is the u of t over here. So the output can be depicted as t minus capital T plus t into e power minus t by t. This we have already discussed in the inverse Laplace domain. So if we kind of plot this with respect to this input, this dotted line shows the input which is being fed into this first order system, and this curve shows the output which is being depicted by this equation. So this is how we can analyze the first order system based on different test inputs. So that's it for today, guys. Thank you for listening this amazing class.